have like a student rate in there?
Mm-hmm.
Is it like, could I get that at some point for the student rate? Because I didn't get it because I know I need to come to the lab to make myself do it. And not be distracted.
You can get the student rate up until the day you graduate.
Okay.
And then after that, when you go start teaching, you get them to buy it for you.
Oh.
But they can't buy it on student rate. They'll have to buy it on education rate, which is a little bit higher than the student rate. And all of that's being recorded. Okay, so let's talk about how to factor these polynomials. Well, I can if I'm factoring it in the rationals, because that means I have rational coefficients. So let's factor x to the 8th minus 16. So, yeah, we haven't factored in forever. How do we factor?
X to the 4 minus 4. And that can be reduced too.
Yeah, that can be reduced to
X squared minus 2. Plus 2. X squared plus 4.
Mm-hmm.
And now we...
And that's in the rationals, right?
Mm-hmm.
So, let's write this. And now we have to factor, where'd the cursor go? In the reals. Well, except we can have square roots of numbers in the reals, right? Yeah, we're going to have x minus root 2, x plus root 2, and then x squared plus 2, x to the 4th plus 4. And now,
Complex.
yep,
Or real.
except I didn't remember the notation for me. I wanted to remember the font for me. It's not going to do it. It'll do that for me in my office. But in the complex plane, what does this become?
Well, it's still the...
The beginning part stays the same, right?
Yeah. So we're going to have X to 2I.
Yeah. X plus 2i. X, yeah. Oh yeah, these are root 2i. I'm going to put that I in front of the root 2 so we know it's not underneath this square root.
Good call. Tab button.
I did. Yeah, that's how you, if you're inside the box and hit the tab button, it'll put that box out there.
I accidentally do it all the time. And then I wanted to do it yesterday.
And you couldn't remember how. Yes. And then tell me about x to the 4th. X squared plus 2i and x squared minus 2i. You have a homework problem very similar to that. You'll like it. Okay. Also, you have a homework problem similar to this one. Someplace here. See if it gets... Yeah. Okay, that got the numbering back. So, find the greatest common divisor. That's not the hard part. The hard part is writing it as a linear combination when we're done. And you have to do that for your solution. So we're going to write it as a linear combination of the two values. So we're going to actually, this is where you'll be somewhat thankful you actually have this program, because you can actually make the program do the division for you. Yeah. We're going to do put this, and we'll tell it to divide it by, where's my division symbol? I cannot see it. I really should take you guys up on making this font size bigger.
You really should take us what?
There it is. On how to make the font size of the boxes bigger.
Oh, I know that.
Yeah, you can make them bigger. So, compute. Oh, it's not going to do it that way.
That's kind of, that doesn't really help us.
Sometimes it doesn't do that.
Sometimes.
Sometimes it doesn't do what you want it to do. I forget how I made it do it. I made it do it the other day, and I didn't use division. I might have made it a fraction.
GCD. Did I?
No. We actually are going to do the division part of it. Let me just do it by hand. It'll be easier. And yours on your homework, you're going to do by hand. I can do it on the scratch. Yeah, we're missing someone. James is not here. And Adam's not here. Yeah. So let's do it by hand.
You could send through it, like,
Yeah. Tell you what. We'll get reconnected momentarily. It's his goal in life. Wing this thing. Yeah, this is all being recorded. Well, we're just commenting on his success at making jokes, so. Okay. Oh, isn't that fascinating? Let's get a white screen on. File, new document. There we go. Now it's working. Okay, we had x to the 24th minus 1 and x to the 15th minus 1. So we're going to do our division, and you guys all know how to do this. Yeah, you better know how to do this, you guys being tutors and all. How many times does x to the 15 go into x? Yeah, x to a what power? Ninth power?
Yes.
So that's x to the 24 minus x to the 9. Subtract it. You're going to have an x to the 9th minus 1. And x to the 15th doesn't go into that. So I'm going to keep track of it over here on this side. And you're going to have x to the 24 minus 1 is equal to x to the 15 minus 1 times x to the 9 with a remainder of x to the 9th minus 1. Okay? I'm not writing it in that form. What I'm doing is, this is a remainder. So you write your answer, what you're getting is your divisor times your, plus your remainder. So this is, yeah, the answer equals x, qx plus r, whatever, that form. And then we're going to divide again because we haven't gotten down to a constant polynomial yet. When our remainder is a constant, we're done. Preferably when it's 0, we're done. So we start with our x to the 9 and x to the 15. We're going to have x to the 9 minus 1. Divide that into x to the 15th minus 1. And x to the 9 goes into x to the 15 how many times? X to the 6. So we have x to the 15th minus x to the 6th. When I subtract that, I get an x to the 6th minus 1, which is smaller than x to the 9th in degree. So we have x to the 15 minus 1 is equal to x to the 9 minus 1 times x to the 6th plus x to the 6th minus 1. Then divide it again. And we're going to use x to the 6 minus 1 and x to the 9 minus 1. Way different, yes, we did. And we proved the division algorithm in history and math, but we used that infinite descent idea. So then x to the 6 goes in x to the 9, x to the 3rd. So we're going to have an x cubed minus 1 left over. So we have x to the 9 minus 1 is equal to x to the 6 minus 1 times x cubed plus x cubed minus 1. And then we still don't have a constant polynomial, so we have x to the 6 minus 1 divide into,
Wait, don't we do x to the 3 minus 1?
yeah, I got them switched. X to the 3 minus 1, x to the 6 minus 1, how many times? X to the 3rd. So x to 6 minus x to the 3rd. It does look familiar, doesn't it? So we get an x to the 3rd minus 1. Now, does that go in? Yeah, plus 1. So then when we write it, we have x to the 6 minus 1 is equal to x to the 3rd minus 1 plus, times x cubed plus 1 with a remainder of 0. That means that our greatest common divisor is the last non-constant polynomial. Does that make sense? That's the process for it.
I've probably been talking about this year, the fact that we finally solved for it.
Yeah, we finally solved for it. So, the GCD of x to the 24 minus 1, x to the 15 minus 1 is equal to x cubed minus 1. Now we have to, and that's the first part of our answer. Now we have to solve it, and we're going to solve it as a linear equation, and we're going to go backwards. You're going to start where you found your GCD, and you're going to solve for that equation first. So you're going to have x cubed minus 1 is equal to, and then you're going to have x to the 9th minus 1 minus x to the 6th minus 1 times x cubed, because I just solved this equation right here for x cubed minus 1. You guys see that? You start there. You're going to go reverse all the way through those equations that we wrote down. We didn't write them down just for our own edification. We're going to use them. So if you go up one equation, you have x to the 6th minus 1 equal to, solve that one, you're going to have x to the 15 minus 1 minus x to the 9 part. So I'm going to plug that in. I'm going to use big parentheses. Okay, so there's our first back substitution. But am I missing an x cubed? Yes, I am. Times the x cubed. Yeah. Good catch. Now, all I'm going to do is go back one more equation.
To get back to the 24.
Yeah, we have to go all the way back to the 24. So we're going to go back to this one right here. And we want it in terms of x to the 24 and x to the 15. So we're going to solve that equation for x to the 9th minus 1 and plug it into the one we have where we have x to the 9 minus 1. That makes sense? So let's see. Hopefully I can remember. I better write this on the board because I have to scroll down.
2x to the 9 minus 1.
Yeah, we have two of them. So we have to plug it in twice. Yeah. So x to the 24 minus 1 minus x to the 15 minus 1 times what? X to the 9th. Okay, there's our equation. They're written down because I have to scroll down now. Okay, so for our first one, we have x to the 24 minus 1 minus x to the 15 minus 1 times x to the 9th minus And then we have x to the 15 minus 1 minus, plug it in here again, x to the 24 minus 1, two sets of square brackets, minus x to the 15 minus 1 times x to the 9. And then don't forget you have to get your x to the 6th in there. This is ugly. Sorry about that, guys. Close the big brackets, and then we have the x cubed on the outside that Haley caught. So I'm going to move everything over here. Now we're not multiplying these all out. We want to keep our x to the 24 minus 1 and x to the 15 minus 1. So let's look at our x to the 24 minus 1. I don't have that in common to both of them, so I'm just going to write the x to the 24 minus 1 out in front. That's all by itself. Now let's factor out our x to the 15 minus 1, and we have it, oh wait, I have an x to the 24 minus 1, I lied. We have x to the 24 minus 1 right here sitting off at the end. We have a minus sign and a minus sign that goes with it, so that looks like it's going to be a plus. And then this x to the 6th,
What are you doing?
let's simplify it out before I factor it out. This is where a scientific notebook is nice, but it's not behaving today. So let me write this out. X to the 24 minus 1 minus x to the 15 minus 1 times x to the 9. And I'm going to start inside our parentheses here. We have x to the 15 minus 1. And this has a square brackets with an x to the 6th. Let's take the x cubed with our x to the 15 minus 1. Does that look right?
Yes.
Wait, isn't the x cubed on the outside?
Yeah, the x cubed
Oh, yeah,
is
you're
on the
right.
outside of everything. So that means it should go with this x to the 15 minus 1.
Yep.
And then it also goes with this x to the 6th.
Yeah. Yeah, the x to the 6th. Okay.
Yeah. And then that's x to the 6th and x cubed, and that goes with that x to the 24 minus 1. That looks right. So that's going to be x to the 9 minus x to the 24 minus 1 times x to the 9. And then with the last one, we're going to have x to the 6, x to the 9, and x cubed. So x to the 18. And that minus gives us a plus. Does that look right?
Yeah.
Scroll it up a little bit. Because this x cubed went on the end right out, I mean x to the 6 goes right
Is that
there.
not a minus,
And then
though?
x cubed goes on there. Well, I didn't take this minus screw yet.
Oh, you have, oh, okay.
I have
I
two
didn't
sets
see
of
that,
square
that big
brackets.
bracket there.
Yeah. Would help if I'd use curly brackets or something different. Okay, so then let's take that minus sign through. So this becomes minus x to the 15 minus 1 times x cubed plus x to the 24 minus 1 x to the 9 minus x to the 15 minus 1 x to the 18. Now we can factor out our x to the 24 minus 1.
Sure.
Sure, I know we can do this.
Why are we factoring out x to the 24 minus
Because we have to write it as a linear combination of x to the
1
24 minus
plus
1 and x to the 15 minus 1.
9.
1?
So 1 minus, let's see,
Plus.
plus
That's 9.
x to the 9th. Is that the only ones? That looks like it. And then x to the 15 minus 1.
Might as well subtract it.
Are they all negative? Yeah, they are. So let's minus it then. X to the 9 minus plus x cubed plus x to the 18. There's our linear combination.
Oh. Yeah.
I'm never going to remember that to type it down on the other page.
Do you have to?
It's actually not hard to do. I'll post a file that has it in it so you can see it done in Mathematica.
Don't we?
I mean, send you from your book. I just can't remember how I did it. Don't we? Can we?
I'm having a factoring speaker here. When we take x into the equal minus 1L.
Uh-huh. We have a 1 from the first one.
Yeah, shouldn't that be in brackets though?
Meaning,
Well.
you take whatever's multiplying the first one and whatever's multiplying it over here. So you put those inside your parentheses.
Yeah. That works.
Yeah. That's the linear combination. You have one homework problem that does that. Only one, yeah. I was going to let you guys do this, but I'm sure you guys can figure this out on your own. But I want you guys to start working on at this point. I'll get that plugged in again in a second. Is you have 2 homework problems. I think one of them is proving Euclid's lemma. And I forget what the other one is, but they're mimics of proofs that the book does. So, yeah, try and mimic the proof of Euclid's lemma for the integers. Go ahead and start working on that, and then, let me see where that is. Yeah, number 3, that's that right now. Mimic the proof of Euclid's lemma for the integers. Let P be an irreducible polynomial. Assume if P of x divides A of x times B of x, show that P has to divide either A or P divides B. Mimic the proof that they do for the integers. That's in chapter 21 or something like that. I'll tell you what page that is. See if you can figure that out. If you have questions on that, let me know. Let me tell you. Let's see. This is chapter 22.
What was that name?
Yeah, page 221. And the proof of it's in there. So yours isn't going to be that much longer than what theirs is.
That much.
It's a little longer because you have P of x's instead of just P.
Gotcha. So we are doing the straight, the E1 straight out of the book, but you were saying the copy it off, use the integers one as an example.
Yeah, the
Not
integers
doing
one
it.
is your example. So you're going to mimic the integers, but you're trying to do the homework problem E1. And that is a homework problem. And so I'm going to come around and look at your outlines, but before I do that, I am going to hand back homework. I've been carrying this around for a couple of days now. Then I'll look at your outlines.